Hello students, welcome back to this new session. Now before I begin with the problems on Cauchy's integral and Cauchy's generalized integral formula, I just want to give you some key points that you must remember before we begin to solve those problems. Okay, so first of all we have the integral formulas in the form f of z divided by integration of the curve c, f of z divided by z minus a dz is equal to 2 pi I f of a. Now where this f of a was means what, this point a where it was while we were proving the Cauchy's integral formula, you should make a note that this point a was sitting inside the curve c. It was totally inside the curve c here also. Okay, that you have to make a note. Then if it is so, then only the value of this integral will be given like this, or else if it is outside the curve c, then we directly conclude that it is 0. So the main point you have to remember while solving, so you may be asked to work for integration of the curve c f of z divided by z minus a dz, or you may be asked to work for integration of the curve c f of z divided by z minus a to the power n plus 1. A can be anything, n can be anything, and all that. Okay, and so curve c can be any curve which we don't know. Okay, so we have to first see what points, that is very important. We have to first check whether this point a, z is equal to a, is lying inside or outside the curve c. First and the foremost thing we have to do is we have to find out the point a and where it is sitting. Is it inside the curve c or outside the curve c? After we are done with it, suppose if it is inside the curve c, then we directly apply the formula, the Cauchy's integral formula or Cauchy's generalized integral formula to evaluate these integrals. Okay. In case if it is outside the curve c, then what we do is we directly consider that these integrals, I mean the functions which are inside the integrals, they become analytic inside and on the curve c, because the given point is lying outside the given curve. Okay, outside the given curve. In that case, we directly consider it to be 0. The integral over that curve should be 0. I hope that is clear to all of you. So only thing you have to remember, if it is inside the curve, then only we evaluate like this using the integral formula. If it is outside the curve, the direct thing you have to conclude by saying that this integral value will be 0, because the given function is analytic inside and on the closed curve c. Outside it, the point lies outside the given this, so we don't have to consider directly. Its integral value will be 0 by Cauchy's theorem. Okay, so hence we will be doing the problems in this pattern. Okay, so let us continue with the problems and see how to work in detail. Now here is one problem for you. Evaluate integration of the curve c, e to power z divided by z plus I pi dz over the curve c given by first curve. You have to consider mod z is equal to 2 pi, mod z is equal to pi by 2, mod of z minus 1 is equal to 1. So for all these three curves in detail we have to discuss. So to begin with, I'll start my solution like this. Okay, just compare the integral formula with the given thing. Okay, you have f of z is equal to e to power z. Okay, e to power z, first thing. Second thing, you have in place of z minus a, you have got z plus I pi. So if you want to write it, it will be z minus of minus I pi. Is it not? Okay, so I can write this as, so like this. Okay, so a is equal to minus I pi, I can write. Is it not? Yes. So this is one thing. We have found the point now. Yes. Now let us consider the first part. You have mod z is equal to 2 pi. What do you mean by mod z is equal to 2 pi? It represents a circle with center as the origin and radius 2 pi. Look at this. So we'll draw the circle now. Center is the origin and radius is 2 pi. Okay, so this is 2 pi, the radius. This will also be 2 pi. This will also be 2 pi. Here also it will be 2 pi. Now a is equal to minus I pi. Minus I pi means this, I told you this is imaginary axis. So minus I pi, it comes in the lower this. This is 2 pi means I pi will be here. And this is also 2 I pi only, because this is imaginary line for us. Okay, so I pi minus I pi comes here on the lower negative y-axis. This is the point. Okay, so you see that this point is lying inside the curve C. this is our curve, this is our circle C, where you see that this point A is equal to minus I pi lies inside the circle. Okay, yes, clearly A is equal to minus I pi lies inside the curve C. So since it is lying inside the curve C, yes, so by Cauchy's, since when it is lying inside the curve C, just now I had given a note, you have to apply Cauchy's integral formula and solve for its solution. Therefore, integration of the curve C, f of z divided by z minus a dz by Cauchy's integral formula, it is 2 pi I into f of a, right? Yes. So provided this A should sit inside the curve C, and we have A is equal to I pi, it is also sitting inside the curve C. Therefore, the integral value, integration of the curve C, e to the power z, because our f of z is e to the power z, divided by z minus of minus I pi, because in denominator you have z plus I pi. So it will be, yes, dz will be equal to 2 pi I into e to the f of minus I pi. Yes or no? Minus I pi, because a value is that. So yes, 2 pi I into, what is f of z for us? F of z is this. So f of e to the power minus I pi will be e to the power minus I pi. Right? So it will be 2 pi I into, what is its value? It is cos of pi minus I sin pi. Yes, cos pi minus I sin pi. E to the power minus I pi is this. So cos pi is minus 1, sin pi is 0. So it will be minus 2 pi I. This is the solution for the first part. Okay, A part. Okay, along this curve it is this way. Okay, now let us work for the second curve. We have mod of z is equal to pi by 2. The second circle is mod z. This is also a circle with radius is equal to pi by 2. So if I draw the circle, will not be something like this? Now since this time the radius is pi by 2, yes, so this will also be pi by 2, but in negatives this pi by 2. Here also it is pi by 2. This is the origin for you. Now the point A is equal to minus I pi. Where is it? It is beyond this. If this is pi by 2, minus I pi by 2, I can write minus I pi comes here, which is outside the circle. So clearly the point A is equal to minus I pi lies outside the circle, or outside I will write mod z is equal to pi by 2 directly. That itself is a circle for us, right? So therefore, since it is lying outside the circle, and anyway on this complete curve it is 0 only, right? I mean according to Cauchy's theorem, we know that whenever the function, except this point, everywhere it is analytic, yes or no? So therefore, integration of the curve C e to the power z divided by z plus I pi dz, directly we have to conclude that it is 0, because the given point is lying outside the circle. Hence the solution. Let us solve the last point. So here the last point was mod of z minus 1 is equal to 1. Let me verify. Yes, mod of z minus 1 is equal to 1. Okay, so let us draw this circle as well. Here the center is, okay, it's yes, the center is 1 comma 0 and radius is 1. Look at this, z minus a, this point represents the center. Okay, so in general, the equation of a circle in complex form, mod of z minus a is equal to r, it is written like this. Okay, here a represents center, r represents the radius. Similarly here 1 is there, so center is 1 comma 0. So let us draw the circle here for this particular example. Okay, Okay, the radius is 1 unit. So if I consider suppose this as the point 1 comma 0, this is my center, and since the radius is also 1, so it is passing through the origin. This is the circle. Okay, this is the circle. Now this point, if this is 1, this is 1, this radius is 1, so this becomes 2 comma 0. Okay, yes. Now look at the point a is equal to minus I pi. Pi is yes, what is pi value? Pi value is equal to 3.142, right? So I pi, okay, a is equal to I pi with a negative sign, which is equal to minus I minus I into 3.142. okay, minus I into 3.142. at the most this point comes here for, this is also 1, right? This is also 1, so this comes somewhere here down, negative minus I 3.142, somewhere here it will come, which you can clearly see that this is lying outside the circle, because this is at least 1. If you take it at most, it can be minus I here, yes or no? Because this distance is also 1, this distance is, because that's the radius, yes or no? So it implies the point z is equal to, okay, sorry, a is equal to minus I pi lies outside mod of z minus 1 is equal to 1. This implies integration of the curve c e to power z divided by z plus I pi dz is 0. Hence the complete solution for this problem. If you do have any doubt, do ask me in our WhatsApp group. Okay, continue in my next session with one more problem on this. Till then, thank you.